Hi guys, welcome back to another video. In this video, we're still going through the Ken Stroud Engineering Mathematics book, and we're currently in this lesson going to be covering radians. In the last lesson, we covered angles, mostly converting degrees or angles in degrees to decimals, and likewise converting decimals back to angles in degrees, minutes, and seconds. So in this video, we'll start by reading through the Stroud chapter, and then we'll answer the questions together as well. So let's start. So radians, an alternative unit of measure of an angle, is the radian. If a straight line of length r rotates about one end so that the other end describes an arc of a length r, the line is said to have rotated through 1 radian or 1 rad. So that's fairly straightforward. So you've got a straight line here, right? If you move that straight line up in this direction, but keeping this point the same, you would end up with the line being here, right? You can see that, yeah? So this distance that is covered here is also equal to r. It's said to have moved 1 radian, or another way of saying it is 1 rad. Cool? So, because the arc described when the line rotates through a full angle is the circumference of a circle, which means 2 pi r. So, because the arc described when the line rotates through a full angle, the arc described, well, okay, got it. Because the arc described when the line rotates through a full angle is the circumference of a circle, which means 2 pi r, the number of radians in a full angle is 2 pi radian. Consequently relating degrees to radians, we see that. Okay, so that's very simple. So what it's saying here is that when you've got a point here, and obviously a full angle is 360 degrees, right? So if you had a line here, if you rotated this line, so obviously that's 1 radian, right? If you rotated it from there, let's do it in a different color. If you rotate it from there all the way around, right? The full, I know it's not centered or anything, but if you rotated it around the full angle, such that oh, you went from here, round here, moving it up, right? Back to here, then this full angle is likewise the circumference of a circle. And we obviously know that the circumference of a circle is equal to what? 2 pi r, as is here, right? Cool. So that means that if you rotated a radian all the way around here, right? And so one full rotation of 1 radian, right, is equal to the circumference, then therefore, right, this is the sign for therefore the number of radians in a full circle is what? 2 pi radians. Yeah, very straightforward. Okay, so 360 degrees is equal to 2 pi radians, right? And then we know that pi is 3.14159, etc. Yeah. So if you times that, if you times pi by 2, then you get 6.831. Right, 6.831. So 2 pi is 6.2831, right? So that means that 360 degrees is equal to 6.2831 radians, right? And you can kind of intuitively see that. So if you've got, this is the radian, right? If you rotated it once, right, then there you've got 1 radian. 2 radians, 3 radians, that's slightly more, like let's say four radians, 5 radians, 6 radians, and then 0.28. Now I didn't, obviously that's not drawn accurately, but you get the point. If you did that accurately, you'd see that it'd work out to be 6.2831 radians. Cool. So now what it's asking us to do is it's saying to us 1 degree is equal to how many radians, right? So to work that out is fairly simple. So we have to remember that 360 degrees, right, is equal to 2 pi radians, right? So 1 degree, simple algebra, right? 1 degree is equal to what? 2 pi divided by 360, which is equal to, you can simplify that to pi divided by 180, right? And then now if we use our calculator, pi divided by 180 equals 0.01745, right? If we make that 3 significant digits, 0.0175, right? Obviously round that one up. Cool. So let's check our answer. 1 degree is equal to 0.0175. There we go. So 1 degree is equal to 0.0175 radians. And here you have it explained again. 360 degrees is equal to 2 pi radians. So 1 degree is equal to 2 pi divided by 360, which can be simplified to pi divided by 180, which is equal to 0.0175 to 3 significant figures. Cool. So let's carry on. Often when degrees are transformed to radians, they are given as multiples of pi. For example, 360 degrees is equal to 2 pi radians. 180 degrees is equal to pi radians, obviously. So 90 degrees, being half of 180, is equal to pi divided by 2 radians. And then obviously 45 degrees, which is again half of 90 degrees, is equal to pi divided by 4 radians, and so on and so forth. So we want to now work out what would be 30 degrees, 120 degrees, 270 degrees, written as multiples of pi. Cool. So we've got 30 degrees here. So if we keep in mind, what I like to do is I like to write out 360 degrees is equal to what radians? 2 pi, right? Yeah. And 180 is just 180 is half of that, right? So 2 pi divided by 2, which is actually just pi, right? Then you've got 90, which again is half of that, so it should just be pi divided by 2. Now, obviously, you can just keep on doing this. So, for example, you've got 45, which is equal to what? Pi divided by 4, right? So, what I do is I look at these 360, 180, 90, and 45. How can I get these three, 30, 120, from these, right? Once I can get that, then I can figure out what it is in terms of radians. So if we take 30 for example, this 90 degrees here, obviously 30 is just 90 degrees divided by 3. So if we take pi over, this is supposed to be pi over 2 here. Don't know what that says, but yeah, that's supposed to be pi over 2 there. So 90 degrees is pi over 2. Then 30 degrees would just be pi divided by 6, right? And 120, well, how do you get 120 from either this 30 degrees one, 90 degrees, 180, 360, or 45? Well, you could times this by 4. Another way you could do it is you could work out 60. So 60 degrees would be pi divided by 3, right? Because it's just double this, right? And then if you doubled that again to get 120, what's this times 2? You'd get 2 pi divided by 3, right? Then how would you get to 270 to do this one? 270 degrees. You'd get to 270 degrees by doing 90 degrees times 3, right? So what's 90 degrees in terms of pi radians? You'd get pi divided by 2 times 3, right? Because 90 degrees is equal to pi divided by 2. So pi divided by 2 times 3 is equal to what? 3 pi divided by 2. And that's it, equal to 270 degrees. So let's check our answers. We've got 30 degrees here, right? We've got 120 degrees, and we've got 270 and 3 pi over 2 equals 3 pi over 2. Yep. So let's find our answers. Here we go. So we've got 30 degrees is equal to 180 divided by 6, or pi over 6, right? That's what we got. 30 degrees is equal to pi over 6, and we worked that out because of this, right? Cool. So 120 degrees is equal to 2 times 60 degrees, which is what I did. So I doubled 30 degrees to get 60 degrees, and then doubled that again to get 120 degrees. So 2 times 60 degrees, which was 180, 180 over 3. So 2 times that would be 2 pi over 3 radians. Yep, we got that right as well. And then 270, like I said, 3 times 90 degrees is equal to 3 times 180 over pi, over 2, sorry, which is equal to 3 pi over 2. Correct again. So how would we work out 1 radian? What is 1 radian equal to in terms of degrees to 3 decimal places? So the way that we work this out is we remember that 360 degrees, right, is equal to what? 2 pi r. So if you wanted to just isolate this r by itself, how would you do that? You would divide both sides by 2 pi, right? So that would give you 360 divided by 2 pi equals r. So what would r equal? R is equal to, so we've got 360 divided by 2 pi, which is equal to 57.2957. And they usually want it in 3 significant digits, so 57.296 is R. Let's check our answer. 57.296. Lovely. So because 2 radians is equal to 360 degrees, 1 radian is equal to 360 divided by 2 pi, 180. So they're simplifying it here. 180 is equal is 360 over 2 pi is equal to 180 over pi, which is equal to 57.296. Cool. So the degree equivalence of 2.34 radians, pi over 3 radians, 5 pi over 6 radians, and 7 pi over 4 radians are. So they want us to work this out. Cool. So what was the first one? The first one was 2.34 radians. 2.34 radians. So 1 radian is equal to 57.296, right? And it's also obviously equal to 180 over pi, right? Because it's also equal to 360 over 2 pi. Yep, this is what we just showed here. 1 radian is equal to 360 over 2 pi, or 180 over pi. Doesn't matter. These are all the same things, right? Also 57.296. So what we could do is we could just do 2.34, and we can multiply it by either this, by this, or by this, The convention is to multiply it by this. That's what most people do. So we'll do the same. So 2.34 times 180 divided by pi is equal to 2.34 times 180 divided by shift pi is equal to 134.072, or to round it up, 134.1, right? So 2.34 radians is equal to 134 degrees. Cool. What's the next one? We'll do this one in a different color. Pi over 3. Cool. So pi over 3 radians is equal to, so remember, 180 over pi, just the same as we did last time, times 2.34, which is what we was finding previously, right? So now we've got pi over 3 radians. So we would just do 180 over pi times pi over 3 radians, right? Now, you could use a calculator here, but you shouldn't need to. So if we just cancel out, right, then you're left with 180 divided by 3, right? 180 divided by 3, which is equal to what, right? If you can't follow this, that's fine. Don't worry about it. Just do it in a calculator, and you'll see that it'll come out to be 60 degrees. So pi over 3 radians is equal to 60 degrees. Let's do the next one in a different color. So cool. So 5 pi over 6. So same again. We can literally just multiply 5 pi over 6 times 180 over pi. So let's do 5 pi divided by 6 multiplied by 180 divided by pi, right? Which is equal to 150 degrees. All right, now the last one, I want you to pause the video and you try it. So we've got 7 pi over 4. All you have to do is literally just multiply it by 180 over pi. So 7 pi, so we had 7 pi over 4, I believe it was. Yeah, 7 pi over 4. So all you have to do is times it by 180 over pi, and that gives you what? Can I edit this one? Yes, I can. 7 pi. 7 pi over 4 times 180 over pi equals 315. Let's check our answers now. So we've got 315 degrees, which is correct. We've got 150 degrees, which is correct. We've got 60 degrees over here in green, which is also correct. And we've got 134.1 over here in pink, which is likewise correct. There you go. So that's how you go about converting radians to degrees. Now, you could remember this method, but this is a bit time consuming. It's usually a lot easier to just go, or it is 100% easier to just go with times in by 180 over pi, as you can see here. This is always going to be the best method to do. So whenever you want to do that, that's if that was a bit confusing, it took me quite a while to get my head around all of this. So just rewatch the video again, and if you have any questions, just leave it down below. I'll be happy to help. Thanks for watching, and as always, both these 2 pages of notes will be linked in the description below, so feel free to check them out, and I shall see you in the next one. Peace.